Hello, this is Ms. DB, and today we are going to learn more about quadratic functions. We will be discussing Chapter 5, Section 2 on properties of quadratic functions in standard form. We will want to do a lot today. We're going to define, identify, and graph quadratic functions, also figure out if we have a maximum or a minimum in our problem, and then use those to solve problems as well. So when you transform quadratic functions from the previous lesson, we saw that if we reflect the parent function across the y-axis, it's exactly the same. So that means that the quadratic function of f of x equals x squared, or y equals x squared, is exactly the same as g of x equals parentheses negative x and then squared. Because if you take a negative number and square it, you get a positive number. So it's the same exact thing. This shows that parabolas are symmetric. The axis of symmetry is the line that cuts the parabola exactly in half into two congruent pieces. It goes through the vertex. So you can see if the vertex is HK, the line of symmetry, this red dashed line here, would cut that into two congruent pieces. The axis of symmetry is a vertical line, and we know that vertical lines are always of the equation x equals and then the x coordinate that the line goes through. So if the vertex is hk, where h is the x coordinate and k is the y coordinate, then the equation of the axis of symmetry would be x equals h. So here we have a quadratic function in vertex form. And from this, we can identify the vertex, and then we can find the axis of symmetry. So first of all, remember that vertex form is x minus, and we have x plus. So if we just thought about this as being x minus a negative, that's the same thing. Then we can find the h part, because the general vertex form, let me just write this as y equals, or f of x equals is fine too. And then it is, so there's the x minus h part of it. And then the other part of the vertex is the plus k part. Now there might be a number here. I'm just going to call it a for now. All right, so because all we really need to know, if they are just asking you for the axis of symmetry, we really only need to know the x-coordinate of the vertex. And we can find that from the equation. It is the opposite of that number. And then the equation will be x equals that number, because an equation has to have either x equals or y equals in it. You can check it by graphing it. Here it would look like on a graphing calculator here. I graphed it in Sketchpad, which you can see gives you a little bit more detail. Here's the function that I graphed here. And then I graphed the equation of the axis of symmetry that I thought it was, x equals negative 5. And you can see that that indeed matches. It goes through the parabola exactly so that it splits into two pieces, so it's symmetric. And the vertex would be right here. And again, this question didn't ask us to find the vertex, but we could from the graph as well, or we could check it. Here's another example. H is 3, so the equation of the axis of symmetry will just be x equals 3. That's really all there is to writing the axis of symmetry. You can check with either a graphing calculator or with Sketchpad, and you should find that you get the same thing. There is a couple of these that might be a little bit different. Let's see. They're all written in vertex form already. Yep, so there really isn't much to this. Let's do number 4. This would be h equals negative 1. So therefore, the axis of symmetry would be x equals negative 1. The axis of symmetry always goes through the x-coordinate of the vertex. So those aren't too bad at all. All right, another useful way that we can write quadratic equations is called standard form. Standard form is when you have a, which is some number, some real number a, times x squared plus b times x plus c. And a can't be 0 because then you just have a linear equation. When you look at what the coefficients a, b, and c are, you can determine properties of your quadratic. So here's our vertex form here. Remember, a is the number multiplied in front, and then h is the x-coordinate of the vertex, and k is the y-coordinate of the vertex. If we multiply, boy, that went fast. It's all automatedly going to go ahead and multiply really quick. So how did they get x minus h squared to be x squared minus 2xh plus h squared? Remember that x minus h squared is not x squared minus h squared. It means x minus h times x minus h. And then you would have to FOIL this together in order to find what this would be multiplied together. So x times x is x squared. X times negative h is minus xh, and then we have another minus xh. So minus 1xh minus 1xh is minus 2xh, and then the last times the last would be minus negative h times negative h is positive h squared. Then they multiplied each of these terms with the distributive property, multiplied each one by a, and then you have to add k to the end. So they got ax squared minus a times 2hx plus ah squared plus k. Then they did a little bit of grouping. They rewrote a couple things. And you might be wondering, why did they do all this? They did it so that you can now see that a is a, the number in front of x squared. But b, look at b. b from the vertex form, from the standard form, is equal to negative 2 times ah. And c is equal to ah squared plus k. And that can help us out, especially the b part we're going to use a lot, that the b is equal to this. So this is going to come in handy. So a is a, like I said. It's going to be, it tells you whether it's going to open upwards or downwards, and it tells whether there has been a stretch or a compression. b is negative 2ah. And if you can solve for h, you can see that h is equal to negative b over 2a. That's going to come in nice and handy. Now we're going to have a way of finding the x-coordinate of the vertex. And we can also find the axis of symmetry, because the axis of symmetry is just x equals the x-coordinate of the vertex. So now we have a way to find the equation of the axis of symmetry. And then c is the y-intercept. So when x is equal to 0, you get that c equals k, so therefore that's the y-intercept. All right, so let's see. We've got here that this is our standard form, f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. Then the parabola has these properties. If a is greater than 0, the parabola will open upward, as in this example. If a is less than 0, it'll open downward, like this. The axis of symmetry is the vertical line, x equals negative b over 2a. Here's the vertex. The x-coordinate is the same as the second part of the axis of symmetry, because we know they're the same. To find the y-coordinate of the vertex, you need to take your answer and plug it back into the equation. There's no shortcut for that. And the y-intercept is just c. And we already talked about that. Okay, so let's talk about everything we can figure out from the quadratic function graph of this. F of x equals 2x squared minus 4x plus 5. Does it open upward or downward? Well, here's our a. And a is positive, so it opens upward. Okay, then the axis of symmetry. The axis of symmetry we found was going to be equal to x equals negative b over 2a. b is negative 4. A is 2. So you just plug those into that little equation and simplify, and you get negative 4 over 4, which is negative 1, but you have a negative in front. So negative negative 4, or negative negative 1 is 1. So the axis of symmetry is x equals 1. Now we have to find the vertex. We know that the x-coordinate of the vertex is 1. So we plug that back in and we solve and see what we get. So 2 times 1 squared would be 1, minus 4 times 1 is 4, plus 5. So 2 minus 4 is negative 2, plus 5 is 3. So our vertex is at 1, 3. X equals 1, y equals 3. The y-intercept is just c. All you have to do is say, oh, it's 5. So that one's really easy. So we found all kinds of stuff out about our function. And you can graph the function, and then you can check those things that you found. You can either graph them in Sketchpad, which I recommend, or you can graph by hand, which you have to find some other points to graph if you're going to do that, or you can use your graphing calculator. Here's a graph by hand. They started with putting the vertex on. They knew it opened upward, and then they put a couple more points on, and they found this. Okay, here is a function. Here, let me just go back to this real quick. The axis of symmetry was x equals 1. Yep, that matches. The y-intercept is 5. I didn't mention that. All right, here's another example. This is negative x squared minus 2x plus 3. So does it open upward or downward? Downward, because a is negative 1. This would be negative 1. The axis of symmetry, we have the equation x equals negative b over 2a. b is negative 2 and a is negative 1, so you substitute those in and you get the axis of symmetry as x equals negative 1. Then we find the vertex. We already know the x-coordinate of the vertex is negative 1, so we plug negative 1 into the function and we get 4. So the vertex then is at negative 1, 4. The y-intercept, that's the easiest part, is just 3. And now we can put those things together to graph the function. Again, you can use your Sketchpad or your graphing calculator to help you do this. So here's the sketch of the axis of symmetry at x equals negative 1. We know that the vertex was at negative 1, what was the vertex? Negative 1, 4, sorry. Negative 1, 4. So that would be here. We know it opens downward. We know that the y-intercept is at 3, so this side has to be matching. And then you would just try to, it's hard to draw this with a pen on the computer, but try to draw a nice smooth curve that goes through those points. And check it. Okay, here's an example from your worksheet. First, I'm going to put in what A, B, and C are so I can answer the rest of this without having to keep going back. The graph opens, well, A is positive, so it's going to open upward. The axis of symmetry is x equals negative, and then B is negative 4. 2 times A would just be 2 times 1. So we simplify this, and we'll get 2. So the axis of symmetry is x equals 2. I'm going to put that on here right now. Here's my axis of symmetry at x equals 2, because 4 divided by 2 is 2. Find the y value of the vertex, so you would take 2 and plug it back in. So we'd have 4 minus 8 plus 3, and you'll finish that and you'll get the y value. So then your vertex will be, let's see, we already know it's going to be 2, and then you just have to find the other part. And then that's the same as number 8, or number 9. Oh, I guess 8 just asks you to find the y value. 9 asks you to actually write the whole vertex. So in 9 or in 8, you're just asking for what is the y value. And then the y-intercept is really easy. You just look at the C, and that's 3, so the y-intercept is 3. And then you'll sketch this. You'll need to put your vertex on here, whatever you find for that. And remember, it's going to open upwards, so it's going to be something like this. There's another example. In this one, a is negative, negative 2, so it's going to open downwards. But you'll just go through and fill each of these parts in. This is just looking for the y-coordinate of the intercept. I mean the vertex coordinate. That's what 14 is asking you to find. And 15 is the vertex, and 16 is y-intercept, which is negative 2. I can tell that one easily. All right, if you substitute any real value of x into a quadratic equation, you get a real number. So the domain of any quadratic function is all real numbers. The range depends on its vertex and the direction the parabola opens, but your domain is always going to be all real numbers. Here we have an example of an opening upwards. Of course, the domain is all real numbers. And the range in this one is going to be all the y values greater than or equal to whatever this number is, which is the y coordinate of the vertex. If it's opening downward, the domain is still the same, all real numbers. What changes is the range is going to be y is less than or equal to the y coordinate of the vertex. So in the first example, this is a minimum point. In the second example, this is a maximum point. You need to know your minimum and maximum a lot of times in problems. So the minimum or maximum is the y value of the vertex. It's not the vertex itself, just the y value. All right, this asks you to find the minimum or maximum value. It only can have one of them, never both, and state the domain and range of the function. So we need to know the y value of the vertex. Well, let's find the vertex. First of all, this is going to open downward like this. So it's going to have a maximum point, not a minimum point. This would be the max. We need to find the vertex so that we can find the y value of the vertex, which will be that maximum. The x value of the vertex is 1/3. So we'll use 1/3, plug back into the equation, simplify, and we get 11/3. This one's a little bit messy with all the fractions, but that's okay. So we find that the y value of the vertex is, it's negative 11/3. That means that the maximum value is negative 11/3 as well. Or you could write negative 3 2/3, that would be. The domain is all real numbers, just like the domain is going to be for all of our quadratic functions. The range is going to be all the numbers less than or equal. Look at our graph again. It's going to be y that is less than or equal to whatever that maximum value is, which was negative 11/3. You can graph this to make sure that what you found matches. We found that our maximum would be right about here, and we found that that would be negative 11/3, which is the same as negative 3.66666. Or negative 3.67. So we can find that from our technology, either our graphing calculator or a sketchpad. And then you need to do this to finish up this assignment. You're going to do this for 2 problems. Let's look at number 18. It opens downward, so I know that it's going to have a maximum. In 17, it opens upward, so it's going to have a minimum. In order to find what that minimum is, or that maximum is, you need to know what the vertex is. And at the beginning part of your worksheet, you looked at finding the vertex. So the x-coordinate of the vertex is that negative b over 2a. That's the x-coordinate. Sorry, I hit the wrong button. Negative b over 2a is the x-coordinate, or the axis of symmetry. So we need to use our, what one was I going to do, number 18? Here's our b. B is 15. A is negative 5. So I'm going to find x, which will be negative 15 over 2 times negative 5. So negative 15 over negative 10, which is 15 over 10. And 5 goes into both of those, 3/2, or 1.5 or 1.5. That's the x-coordinate. Now to find the y-coordinate, remember you have to plug that point back into your function, -5 times 1.5 squared plus 15 times 1.5 minus 3. Remember, when you square this, the answer is not 3. It's 1.5 times 1.5. Then multiply that by -5. Then multiply these together and then add the numbers together. So don't forget to do your order of operations correctly. You have to square and then multiply that by 5. Then multiply these and then carry on. So we have to do that to find this one is going to be the maximum. Whatever you find, that will be the max. The domain is all real numbers, which is the same as this kind of fancy capital R, or just write all real numbers. And the range depends on what you find as you finish this. The range is going to be y is less than or equal to whatever you get for your maximum value. All right, let me know if you have any questions, and I will be happy to help you out. Thank you very much and have a great day.